dat proberen. Ik ga proberen.
Eerst een opdraaien.
Waarom zeg je veel?
Maar je hebt geen ervaring. Daar houdt het van.
Kijk je gelijk.
Ik wist dat ik wel gehoord heb, maar het is niet dat ik serieus ben. Daarnaast had ik
Je kan niet.
eerst
Okay, in the back, please be seated so we can start.
Ik heb nooit gevraagd om het zo over uitvesten te
Okay, I'd like to get started. So please be seated. So, in the first lecture, I covered the first sections of chapter 1 of the Bible, right? And I leave the other sections to you because most of the materials in the other sections are just introductions, and we will cover them more deeply in the lectures devoted to each topic. So please make the other sections and do the practical work in the exercises in the Zybook by yourself for section 1. So all the exercises in the Zybook that are in the text, right? I really urge you to make them because I think they're a good way to prepare for the assignments and for the exam. All the labs and the assignments that are in the Zybook are optional. So I think I've hidden most of them just to avoid confusion now in the beginning. But all the the real assignments that you need to make, right, will be on campus, and all the assignments and labs in, so the design labs in design will be optional. Okay, so like I said in the beginning, right, every one of you is using the web on a daily basis. But I want you to think about how it works under the hood, why it works, and most of us are used to it. It's actually, if you see the web as one of the biggest information systems in the world, and I think it is, right, by far. Most big information systems projects that I know of tend to fail. But if you look at huge information system projects, for example, in the Dutch government or for the European Union, there are many more failure stories than success stories. And thinking about why the web is actually successful, while many people in the beginning actually predicted it would fail, is also, I think, a good way to think about this topic. So, I want to do a little exercise. I've never tried it before, so we'll see if it works. So, suppose I want to use my computer to look up the homepage of the VU, right? The university. What do I need? In terms of hardware. What do I need to do that? Just get back to the basics. What do I need?
A device with internet connection.
So
A device.
a device with internet connection. So just write this down. Device plus internet. So what kind of device?
A computer, phone, whatever.
Actually, this is already a remarkable answer, right? You can do a laptop, a phone, a tablet, whatever. It doesn't matter. That's actually, in the history of computing, that's quite special, right? And it doesn't matter what device. It used to be that if you want to work on a specific application, that you need to have a Windows laptop with Windows 10 or a Macintosh with a specific version of macOS or whatever. Right? So that it doesn't matter, and it works on any device, laptop, smartphone, tablet, whatever. It's actually quite special. Okay, so what else do I need? So this is the device with the internet connection. Is it all I need, or do I need more? Different volunteer. What else do I need? What's the device supposed to do? If you look at the screen, it should give you a hint. I need a browser, right? So this is also actually a quite remarkable answer, right? It doesn't matter what I need to do, right? If what I'm planning to, if I'm planning to look up the VU website, if I'm looking up a web shop to do some shopping, or when I want to book a trip, whatever I'm going to do on the web, the first thing I do is start up my browser, if I haven't done so already. So that you can use the browser for anything you want to do on the web. It's also quite special, because it used to be that for every different task, you need a different application. So this was really by design by Tim Berners-Lee. Right? He got really annoyed by all these different programs that didn't work together, and his vision was really, we're going to use one browser for everything. And nobody believed that would work when he said so. Because now people are always going to use different things for different purposes. That you can do everything in one application, nobody believed him. But he came quite far. Right now with the mobile web, where we have lots of different apps, this vision of the browser for everything breaks down a bit, but it has worked for quite some years. Okay, so I need a browser. What else do I need?
We need a host and domain.
You need a host and domain of what?
The website that we're doing.
So I need to know what the domain name is of the VU. Right? So in this case it's simple, it's VU.nl, but I need to know this. So the domain name of the VU. I'm going to intentionally write this down here. Domain name, VU.nl. Okay, so suppose I'm typing this domain name in my browser, and my history, of course, is gonna. So what just happened? I typed in the domain name and I press return. Right. So what just happened? What was the first thing that the browser did? Remember the first lecture about DNS?
HTML GET request.
An HTML GET request. Okay, so pretty close. HTTP GET request, but so the browser sent a request to the server using the HTTP protocol, using the GET method. Please give me the homepage of the view. Right? But before it could do this, it needed to contact the web server, the machine that runs the website of the view. How did it do that? So that's coming before the HTTP GET.
Get got the IP from the DNS.
Sorry?
Get got the IP from the DNS.
Got the IP from the DNS, right? Because the view, the machine that runs the view web server, it needs to have an IP address, and the browser needs to know that IP address to contact the server and to communicate over the internet protocol. Because with all the fancy web stuff, under the hood, it's still the good old internet from the 60s that is doing the real work. So it does a DNS request to convert vue.nl into an IP address. And what does it use? What protocol does it use to connect? Does the browser use to connect to the view using the IP address? Anyone knows? TCP/IP, right? So TCP is this protocol that's briefly mentioned in the first part of the section of the design book, first chapter. And TCP itself is built on top of the IP protocol, and they usually go together. So people typically say TCP/IP, but they are really two different protocols. So we have IP on the basis for the basic communication, right? TCP to send messages over IP to the browser and to set up a connection, and then we have HTTP built on top of TCP. So maybe the stack I should have put it the other way around. So typically HTTP is on top, IP is on the bottom, but in the historic order, this is the order, right? So this is what happens. HTTP uses TCP, TCP uses IP. Okay, so the DNS says, okay, this is the IP number, the address that belongs to vue.nl. The browser uses TCP to say, please give me your connection with the computer that has this number, right? And then the computer from the view says, yes, that's fine, we have a connection, we can send you messages. What else do we need to set up this connection? So TCP needs an IP number, but it needs one more thing. Another number.
Port.
A port number, right? So which port number are we going to use?
80.
How do you know?
HTTP.
HTTP.
Yeah.
What does it mean, HTTP 80?
HTTPS 440.
Yeah, suppose that 80 is the correct answer. How does the browser know it needs to use 80?
TCP. From TCP.
No, in TCP you can use whatever port number you want.
HTTP.
Yeah, so in the standards, right, in this standards committee, they have decided it's easier if we all use the same port numbers, so then you don't need to remember that. So in the standard it says, well, if we don't use a specific port number, just assume it's 80, and then we're safe, right? And then if everybody does this, then you can just omit the port number most of the times. So it makes it easier for everyone. So, right, so it uses TCP on the IP address on port 80. Very good. So then it has a connection, and then the server says, well, everything is fine. We have a connection between the two, between my laptop and the view computer. We have a connection on port 80. Please give me a message in the protocol called HTTP, because on port 80 I expect messages using the HTTP protocol. And the HTTP protocol is also standard, right? Also a lot of people in committee meetings trying to get consensus of what the protocol should be. Well, the most used protocol they all agreed on was GET, just to get information from one place to the other, from the server to the client, to the browser. So my browser is going to use HTTP, the GET method, to say to the view server, please give me what? What should the browser ask for? I already gave it away, right? I want to see the homepage. So what do I need to get the homepage? What does the browser request? So if you look at the URL bar, can you actually see this? It actually says, it doesn't say vue.nl. I typed vue.nl, but it says something else. Right? It says vue.nl/nl/index.aspx. I have no clue, but that should be after it. I just typed in vue.nl, return. Right, so what did my browser ask for? Did my browser know this? That this should be asked? So you were right? It was sending an HTTP GET request, but what did it ask for in the GET? What is the uniform name for give me the homepage? Index.html, yeah, that's the file name that corresponds to the. But there's an even shorter way to ask for the homepage. That's what typically comes after the vue.nl. What's the first character that comes after the vue.nl? Slash. Yeah, backslash. And so it asks for the page called slash. And the page called slash is the HTTP standard way for give me whatever you think is your homepage. And I don't care if you call it .nl.index.html or .index.hxp. That's for the server to find out. I don't want to know it. But it gives me just give me the homepage. And I use slash to do that. And how does the browser and the server communicate over HTTP? Is by literally sending messages containing statements like this. Right? So it's all in plain text. Nothing is, if you don't use encryption, if you just use plain HTTP, nothing is encrypted, nothing is in binary encoded. It's all in plain text. You can all see it. Everybody can read it. So if you want to eavesdrop as a hacker, right, it's very easy. That's why people invented HTTPS for secure later. So this is all very basic, simple stuff. Okay, then it gives me the so the server decides, okay, my homepage is this index.aspx thing, and then what happens then? What actually is the homepage? What kind of file do we get back? Anyone? What format? We get an HTML file back. What does it mean, an HTML file? It's a file with text, right? With the text that you see on the page. Let's accept the cookies. So all the text that you see here is also in the HTML. And what else is in the HTML? I used this word in the first lecture. It's markup, right? So this is markup that tells my browser what the computer needs to do, what my browser needs to do with the text. So HTML markup is one thing that is in this file. It looks like these angle bracket things, right? So you have things like HTML between these angle brackets, and then you have a whole piece of text, and then the file ends with end HTML. So this again is all in plain text, nothing fancy. You can just write this down by hand in your whatever editor, and that's what you're asked to do for assignment 1. Okay, so one thing I told you that you can use whatever you find on the internet as a good example for your assignments, right? And in the beginning, that's how how a lot of people actually learned the web before there were official courses like this, but just looking at what was done on other websites and get inspired by that. So, assuming that I'm using the Chrome browser here, what is a good way for my Chrome browser to see actually how this works? Anyone? Because this is also a skill that you need to learn from for the assignments. Sorry? Speak up.
F12.
I cannot hear.
Press F12.
Press F12. Can you do that? Okay. I press F12. And what happened? What just opened? Has everybody seen this before? So what is this called? This is called the Chrome Developer Tools. So in the first section of the Zybook, this is explained. So you can press F12, you can press I think Ctrl-Shift-I, and you can go to the little menu on top, and then go to Tools, Developer Tools, and you get this. It's really useful because everything that the browser does under the hood, you can inspect here. Right? So if your website works fine, then you don't need this. But if the website doesn't work fine, you will wonder, okay, it doesn't work. Why doesn't it work? And you need to inspect what goes on in the browser to find out. And this is really useful. So one thing that the site will do, and we'll close this for a moment, is that it will show reload it. It will actually show all the HTTP requests that go on like this, and you immediately see that I asked for the website, right? That's the first request. That's the HTTP GET request that we're talking about, but that's not the only one. There is lots and lots and lots of other stuff that's going on here. So what else is it doing? So what is this? The second one. So this is the homepage, right? This gives me the HTML document. What is this? What's the second one? Anyone? Look at the file suffix. That you might know.
It's a JavaScript file.
It's a JavaScript file. Exactly. So, and why does it load this JavaScript file?
Probably for the animation on the website.
Probably for the animation. So things like the animation, right? It's not covered by HTML, it's not covered by CSS. So things like that are done by JavaScript, and it's loading a specific file for that. It uses the same HTTP GET protocol messages as it did for the HTML, right? So the fact that there is different content in an HTML file, or a JavaScript file, or an image, or a CSS file, or a video, doesn't matter. It still uses the same protocol. So that's it is still all HTTP. Well, we can go here. What's this? The third one. By looking at the file name, you probably can guess. Right, it says Vue logo, right? So this is the Vue logo of the Griffin. It's in the file suffix SVG. Does that ring a bell? What SVG stands for? It's a typical web standard. It's as typical for the web, I think, as almost as HTML. It stands for Scalable Vector Graphics. So it's an image format that's actually scalable. So it means that if you have a JPEG or a GIF, right, and you enlarge it a lot, it becomes pixelized. You see these big pixels, and you cannot scale it indefinitely. SVG you can scale indefinitely because it's actually a little computer program that tells the computer how to draw the image, and it will just draw the image at whatever scale you want it. Why is it important for the web? So SVG did not exist before the web was invented. Right? And it has to do with this first answer here. why is it important to have scalable images on the web? You can watch it on the TV, on the smartphone. Right? Typically, by the way, your smartphone has more pixels than your TV. But apart from that, right, the idea I think is clear. If you're the Vue website, right, you're a developer of the Vue website, you don't know on how many pixels the screen is that your users are going to view your website. So you need to make sure that it works on very small screens, but also looks nice on very big screens. So a scalable web format is very nice. Well, we can go on and on like this, right? So you will see that there is a lot. So my guess is that after I downloaded the Vue website HTML, the browser downloaded 50 more files with JavaScript, CSS, images, whatever. So how does my browser know what all these file names are, right? So I told him to get to the homepage, but how does it know it needs to ask for custom elements ES5 adapter.js? Where's that coming from? Right, it's nice that the Vue wants to have all these things on their website, but how does my browser know? Anyone? Somebody needs to tell the browser.
It's all linked in the main HTML file that we retrieved.
Yeah, so it's all in the main HTML file, right? So at first it gets the HTML file, it reads the HTML, and in the markup of the HTML, it says, okay, you also need to download this JavaScript file here, that image there, etc., etc. So that's all part of the markup in HTML. And we're going to see, we're going to use the same thing in assignment 1 and assignment 2 to do the same thing. Okay, so this is the HTTP part. What is also interesting is that, if I make it a little bit smaller, there is this toggle device thing. And here you can emulate what the site would look like on different devices. Right, so this is more how the site looks on a smartphone with a small screen, right? And you can manipulate it a bit, right? You can make it, and you can see what the website does if you change it. So that's also something you need for assignment 1. I want you to make a website in plain HTML, right? That looks as ugly with the black text and the blue links as we saw in the first lecture. But then add CSS and make it behave a bit like this one, that it works well on different screen sizes. And that's a website that changes its appearance according to the device. It's called a responsive website. So that's part of the assignment as well. So to do that, right, you can either try if your page works on a mobile phone, which is quite hard because you need to have internet connection, make a web server that serves your website, right? It's all a lot of work. It's much easier just to test it on your local browser, like I'm doing here. Load the HTML file that you're currently developing and use these tools to make sure that it works. Right, all the popular phones are here. So if you want to test if it still works on iPhone 6, right, then you can do that. What is it? On the iPhone 10, it looks like this. On the Galaxy S5, it looks like this. Okay, you can still you get the picture. Right, so that's another nice feature of these developer tools. And the final one, I want to get back to desktop mode. Is this inspector, the HTML inspector? That's in the far left corner. Do you see this? So if I click on this, now if I go over the page, it will, for every element on the page, it will show a little bit of information. What the HTML markup is, what the CSS markup is. I can click on it, I can see the actual HTML markup here, right? So you will see that it's using markup like this with these angle brackets. So something here, there's content, and then there's span, whatever, class. So this is exactly the markup that you need to write yourself in assignment 1. But if you see other pages and you want to know, okay, what's the markup they use for this? I want to use similar effect. Then you can use this tool to inspect how they did it and use that as inspiration. Right? So these developer tools are really nice. One final thing I want to show you is the console. So the browser will put any error message in the console. So if you do something wrong, typically you don't see any error message in your HTML file because typically server-side developers don't want to see your error messages as an end user, so they hide that in the console. Which means that if you make a mistake, you load your page, you think it should work, and it doesn't. You have no clue why. So my own development style is that if I make something myself, I just have the console open all the time because I know I'm going to make mistakes. But if you're human, then you're going to forget one of these brackets, and then weird things happen, and you have no clue why. And you stare at your code, and you cannot find it because this thing is scrolled away 10 lines, and you never see it unless you look at the console and it says in line 1 angle bracket is missing. Right? So I think one of the skills that you need to learn in this course is to read error messages. And step 1 is if you're reading error messages is how to find where the error messages are. And on the web they typically are in your console of your developer tool environment. Now this is for Chrome. If you really hate Chrome and you want to use Safari or whatever, feel free to do so. They all have similar options like this. I got complaints from students before that Edge from or whatever the current Microsoft tool is not very well equipped with tools like this, and they find it actually harder to work in the Microsoft browser than in the Chrome browser. So that's one tip. I don't want to get in the browser war here, but some browsers are easier to work with as others. Also, we need to make sure that the TAs can grade your assignment, right? So if you work in another browser, that's fine, but make sure it at least works also in Chrome. I tell all the TAs that they need to test it in Chrome, and then we get a fair playing field for everyone. Because if you're Windows, right, and your TA is on Mac, or vice versa, and you say, yeah, it also only worked on Safari, but not on Internet Explorer or not on Chrome, and they don't have Safari, then they cannot grade your assignment. So, for practical reasons, not because I'm trying to take a position in this browser war, please make sure it at least works on Chrome. Having said that, I think it's really good to once in a while switch to another browser and to check if your website also works, or your page also works on different browsers, right? Because if it only works on